Hi, I'm Gonju. I'm currently preparing for the Google Cloud Professional Cloud Architect certification exam. For me, the best way to learn is by explaining how things work to others. That's why I decided to create this video series about this exam. You can find all the resources and explanation PDF below in the description. If you enjoy this video, please like and subscribe to support my journey. Let's talk about the data. First, imagine you have a box of different colored marbles. Each marble is like a piece of information. Now, if you write down the colors of all the marbles on a piece of paper, that paper is like your data. It's a way to keep track of all the information about the marbles. In the digital world, data is like the information you write down, but it's stored and managed by computers. It can be numbers, text, pictures, videos, or anything else you can think of. When you use a computer or a smartphone, you're often working with data, like typing text, viewing photos, or watching videos. For a cloud architect, data is fundamental because it's the basis for designing and implementing cloud solutions. That is why we have a thing called Data Lifecycle. The Data Lifecycle refers to the various stages through which data progresses from creation to deletion. Proper management of the data lifecycle is crucial for maintaining data integrity, security, and compliance. Understanding the data lifecycle is crucial for architects when designing cloud solutions. But why? Because managing the data lifecycle in cloud architecture helps you save money, keep data safe, comply with laws, ensure data quality, handle growth, recover from disasters, streamline operations, gain better insights, and reduce environmental impact. Let's start looking at the key stages of the data lifecycle. We will only cover the first 3 stages of the data lifecycle. Other stages, such as data privacy or data deletion, are not covered under this chapter. Let's get started. Data ingestion. Data is collected and brought into the system for further processing and storage. This can be done in batches or in real-time streams. Data storage. Data is stored in an organized and secure manner. Different types of storage solutions are used, depending on the nature of the data, such as databases, data warehouses, or cloud storage services. Data processing and analytics. Raw data is transformed into a more usable format through cleaning, validation, and transformation processes. Processed data is analyzed to extract insights and inform decision-making. This can involve querying databases, running statistical analyses, and using machine learning models. Data ingestion is the process of collecting and importing data for immediate use or storage in a database. It involves obtaining and importing data from various sources such as sensors, logs, or user inputs into a system where it can be processed and analyzed. Real-time streaming refers to the continuous transfer of data from its source to a destination in a timely manner, often with minimal delay. This process allows for immediate processing and analysis of data as it arrives, enabling businesses to make faster decisions based on up-to-date information. Batch processing, on the other hand, involves collecting and processing data in large groups or batches. This approach is typically used when real-time processing is not required, such as for processing historical data or running non-urgent tasks. Pub/Sub, publish-subscribe, is important in real-time streaming because it provides a messaging infrastructure that allows publishers to send messages to a central topic or channel, which are then distributed to all subscribers. This architecture enables scalable, real-time data processing by decoupling the producers of data from the consumers, allowing for more flexibility and efficiency in handling data stream. For batch streaming, where data is processed in larger, scheduled batches rather than continuously in real time, several Google Cloud tools and services are commonly used, such as Storage Transfer Service, BigQuery Transfer Service, Transfer Appliance, and GSutil. These tools and services, except for BigQuery, are designed to simplify and automate the process of ingesting data into Google Cloud for batch processing, allowing you to focus on analyzing the data rather than managing the ingestion process. Next, with data storage, imagine you have a lot of important things like photos, videos, and documents. Normally, you might keep these on your computer or an external hard drive, But what if you want to keep them safe and be able to access them from anywhere? Data storage in Google Cloud is like having a huge, secure digital locker on the internet where you can store all these important things. This means you can save your files in this online locker and then access them from any device like your phone, tablet, or another computer, as long as you have an internet connection. Google Cloud keeps your files safe and makes sure you won't lose them, even if something happens to your own devices. Cloud storage. Think of this as a big, secure digital storage unit where you can keep all your files, like photos, videos, documents, and backups. It's easy to use and can store huge amounts of data. Use case. Cloud storage is suitable for storing data at all stages of the lifecycle, from ingestion to archiving. Lifecycle management. You can set up lifecycle policies to automatically transition data to cheaper storage classes. BigQuery. Imagine a giant data warehouse where you can store and analyze massive amounts of data to find important insights. It's great for businesses that need to analyze large datasets quickly. Use case. BigQuery is ideal for storing and analyzing large datasets, especially for data that needs to be frequently queried and analyzed. Data Lifecycle. Data can be ingested into BigQuery for analysis and then archived or deleted based on business needs. Cloud SQL. This is like having a managed database service where you can store and manage your relational databases, like MySQL, PostgreSQL, and SQL Server. It's easy to set up and maintain, and it's scalable to handle your growing data needs. Use case. Cloud SQL is a fully managed relational database service that is suitable for storing structured data. Data Lifecycle. Data can be stored in Cloud SQL for as long as it is needed for operational purposes and then archived or deleted as per requirements. Cloud Bigtable. Use case. Cloud Bigtable is a high-performance NoSQL database service suitable for storing large amounts of data with low latency requirements. Bigtable is used for real-time analytics, IoT data processing, and as a back-end for large-scale web and mobile apps. Data Lifecycle. Data can be stored in Bigtable for real-time processing and then archived or deleted based on business needs. Bigtable's lifecycle management includes creating tables, storing data, updating and querying data, and deleting tables when they're no longer needed. Cloud Spanner. Imagine a database service that combines the benefits of relational databases with the scalability and flexibility of NoSQL databases. It's great for applications that need high availability and strong consistency. Use case. Cloud Spanner is a fully managed, globally distributed, and horizontally scalable relational database service. Data Lifecycle. Spanner can be used for storing transactional data that requires strong consistency and horizontal scalability. Data can be ingested, queried, and updated in real time, making it suitable for use cases where data needs. Cloud Firestore. Think of this as a flexible, scalable, and real-time database for your mobile and web applications. It's great for storing and syncing data between your users' devices and your servers. Use case. Cloud Firestore is a flexible, scalable database for mobile, web, and server development from Firebase and Google Cloud. Data Lifecycle. Firestore is suitable for storing real-time data, such as user profiles, chat messages, and other document-oriented data. It can be used for data that needs to be synchronized across devices and platforms. Data processing and analytics involve taking raw data and transforming it into useful information. Think of it like cooking. You start with raw ingredients, data, follow a recipe, processing, and end up with a delicious meal. Insights. Data processing and analytics are crucial because they help us make sense of the data we collect and use it to make better decisions. Let's mention some tools to process the data. Dataflow. Dataflow is a fully managed stream and batch processing service that executes data processing pipelines. It supports both batch and stream, real-time processing, making it suitable for a wide range of data processing tasks. Key features. Dataflow provides a unified programming model for both batch and stream processing using Apache Beam. It automatically scales to handle large datasets and can integrate with other Google Cloud services such as BigQuery, Cloud Storage, and Pub/Sub. Use cases. Data transformation, ETL, extract, transform, load, real-time analytics, and data migration. Data Prep. Purpose. Data Prep is a data preparation tool that helps clean, enrich, and transform raw data into a usable format for analysis. It provides a visual interface for data wrangling tasks, making it accessible to users without extensive programming knowledge. Key features. Data Prep offers interactive data cleaning and transformation capabilities, including automatic detection and suggestion of data cleaning operations. It can handle large datasets and Dataproc. Purpose. Dataproc is a managed Apache Spark and Apache Hadoop service that allows you to run big data processing and analytics workloads in a cloud environment. It provides a scalable and cost-effective way to process large datasets. Key features. Dataproc supports popular big data frameworks such as Spark, Hadoop, Pig, and Hive. It offers integration with other Google Cloud services and provides features for cluster management and auto-scaling. Use cases. Big data process. Google Cloud offers a range of analytics tools that cater to different needs and use cases. Some of the key analytics tools in Google Cloud include conducting data analysis using BigQuery, machine learning models with AI platform, visualization tools, Looker, Data Studio. I feel like it is important to talk about real-time versus batch processing pipelines. Google has some suggestions when it comes to process batch data. Extract the data. Use tools like Cloud Storage Transfer Service or Data Transfer Service to extract data from on-premises or other cloud sources to cloud storage. Google Cloud Storage for landing source data. Transform. Use tools like Dataflow or Dataproc to transform the loaded data into a usable format for analysis. Dataflow for performing transformations on the source data load. Use tools like BigQuery or Cloud SQL to load the extracted data into a data warehouse or database. BigQuery as a destination for the transformed data cloud composer environment for orchestrating the ETL process. Real-time processing. Extract. Use PubSub or other messaging services to ingest streaming data from sources such as IoT devices, sensors, or logs. Transform. Use Dataflow to process and transform the streaming data in real time. Dataflow can handle both batch and streaming processing, making it suitable for real-time ELT pipelines. Load. Use BigQuery or cloud storage to load the streaming data into a temporary storage location. Finally, let's mention a bit about the IoT data lifecycle. Device connectivity. IoT devices connect to Google Cloud IoT Core, which is a fully managed service to securely connect, manage, and ingest data from globally dispersed devices. It supports MQTT and HTTP protocols for device communication. Data ingestion. Google Cloud PubSub is used for ingesting data from IoT Core. We already mentioned about the PubSub, so I will not explain it in here one more. Data processing and transformation. Data ingested into PubSub can be processed and transformed using Google Cloud Dataflow. You can perform real-time data processing, filtering, aggregation, and enrichment using Dataflow. Data storage. Processed data can be stored in Google Cloud Storage for long-term archival or in Google Cloud Bigtable for real-time analytics and fast data retrieval. Data analysis and visualization. You can use Google BigQuery for data analysis and SQL queries on large datasets. For visualization, you can use tools like Google Data Studio or third-party BI tools that integrate with BigQuery. Machine learning and AI. Google Cloud AI Platform can be used to develop and deploy machine learning models for predictive analytics or anomaly detection based on IoT data. AI Platform provides a suite of tools and services for building, training, and deploying machine learning models. In this video, we have explored the comprehensive data lifecycle in Google Cloud Platform, detailing the critical stages of data ingestion, data storage, data analytics, and data processing. We began with data ingestion, highlighting tools such as Storage Transfer Service, BigQuery Transfer Service, and Transfer Appliance that facilitate efficient data import from various sources. Next, we delved into data storage, examining versatile options like cloud storage, BigQuery, Cloud SQL, Firestore, and Bigtable, each catering to specific use cases. We covered data processing, focusing on how Google Cloud's scalable and robust infrastructure supports real-time and batch processing through services like Dataflow, Dataproc, and Data Prep. Lastly, we talked about the real-time versus batch streaming pipelines. Thank you for watching, and we hope this video has provided you with a clear understanding of how to effectively manage and utilize data within Google Cloud Platform.